Okay, students, good morning to all of you. So we are doing objective problems now, na? Yes. So in previous class, I think so 14th question is over, no? Yeah, this 13th is over, 14th also over, 15th also over. 15th question, see, by photoelectric effect, Einstein proved that E is equal to h nu. This he has proved. Okay? Yeah. So question number 17, let us go to question number 17. See question number 17, what they have given? A photocell is illuminated by what? A photocell is illuminated by a source of light. Okay. Which is placed at a distance d from a cell. Okay. If the distance becomes d by 2, then number of photoelectrons emitted per second will be. Yeah, concept is important. Concept for JEE students also it is important. Listen carefully. Number of photoelectrons or photons emitted is directly proportional to intensity of light. More is the intensity of light incident on a metal surface, number of electrons will eject out. This is the concept. Clear? Yeah. And as we know that intensity is nothing but power upon area, and area that too we should take spherical surface means pi r square. If you take diameter it will be upon pi d square by 4, distance square we can say. Okay, yeah, that means intensity is power is same, pi is same, 4 is same, means it is inversely proportional to d power d square, and this intensity is directly proportional to number of photons, means number of photons is inversely proportional to d square, distance square we can say. This is the formula we need to use here. Understood, students? According to the question, you have got the formula. Now, what is n1 by n2? n1 by n2 will become d2 square, distance 2 square upon d1 square we can write. Okay, n1 is n you take, n2 is n2 only you take, because this is a photocell is illuminated by a source of light which is placed at a distance of d from a cell. If the distance becomes d by 2, number of photoelectrons emitted per second will become. So initially n photons are there at a distance of d, and at a distance of d by 2, how many photoelectrons will be emitted? Yeah, so formula will be this, means n by n2 becomes d square by 4 upon d square. This d square cancel, means n by n2 become 1 by 4. Then what is n2, nana? n2 is nothing but 4 times of n, right? Cross multiply them. Yes. So that means when you decrease the distance, number of photons will be more. Yeah. Option 2 is right. Concept is important for JEE students as well as for NEET students also. NEET students, for you also it is important. Clear? Understood? No? I hope you understand it very clearly. Yeah. Next. Let us go to question number 17 over. Question number 18. Nana. Question number 18. Yes, here see. Question number 18. What they have given. Let me check how many students are present. 18 are there, including me. Akshata, Chidambar, Navami, Pradesh, Jain, Pradyusha, Pratisha, Priyanka, Elahani, Priya, Elmi, Prudvi, Sahana, Sunny, Sunny, Shabya, Sunita, Jonah. Jonah coming good. Ritika. What about Vivek? He has been came, no? Oh, wait a minute. I did not. Okay. Now, see question number 18. A graph is plotted between maximum kinetic energy of electron with the frequency of incident photons in photoelectric effect. What is the slope of this curve? See, the slope of this curve gives you h, Planck's constant. Okay, h by e. if you want. Means it will use you Planck's constant. It won't gives you charge of electron. It won't gives you work function ratio of Planck's constant with the charge of electron. Yeah, see here. Here see h by e it will gives you. So Davison RA Millicon he has perform an experiment to disprove Einstein photoelectric equation. So while disproving that, he rather proved that equation, and from that he has got a graph for kinetic energy and the frequency, and the slope of this graph comes out to be h by e. Slope of this graph is h by e. Means it is a ratio of Planck's constant and charge of the electron. Yes, fourth option is right. Third option is wrong. Clear? Conceptual question. You need to know this. Clear, na? Students, understand? You know. Next, question number 18 is over. 19 question. 19 question, what they have given? A photon of energy is 6 electron volt. Photon of energy is 6 electron volt incident on a metal surface of work function 4 electron volt. Maximum kinetic energy of photoelectron. Okay. So energy how much given? Energy is equal to, listen carefully, energy is equal to 6 electron volt given. Okay. Then next work function given. How much work function is? 4 electron volt given. Okay. Maximum kinetic energy of photo emitted electron will be, maximum kinetic energy of photo emitted electron is, according to Einstein equation, is energy, incident energy minus work function. Instant energy is 6 electron volt minus work function is 4 electron volt. This will be 2 electron volt. Yes, this much maximum will be there. Minimum, however, 0. I told you already. Minimum will be 0 always. Maximum is 2 electron volts. Yes, option 3 is here. Direct question it is. Nothing is there to prove this. Okay, next. Question number 20. Light of frequency nu is instant on a metal of threshold frequency nu naught. Then what is the work function? See, work function is nothing but h nu naught. Planck's constant into threshold frequency. This is the work function always. So option 2 is right answer. Okay, direct question. Next, the work function of a photoelectric material is 3.3 electron volt. Then what is the threshold frequency? They are asking. Threshold frequency is what? Okay. See here only they have given threshold frequency nu naught is equal to work function about upon Planck's constant. Yes, work function given how much? 3.3 electron volt. Planck's constant 6.62 into 10 to the power of minus 34 joule second. And now if you directly cancel, you won't get the answer because here see unit is in electron volt, whereas here unit is joule. So we need to convert the electron unit should be same. So it can be written as 3.3 into 1 electron volt is nothing but 1.6 into 10 to the power of minus 19 joule upon 6.62 into 10 to the power of minus 34 joule second. Joule cancel. You will get 1 by second as a unit. So it should be Hertz. Yes, it is. Options are in Hertz. Now calculate 3.3 into 1.6 upon 6.62. If you do this, you will get the answer as 8 into 10 to the power of 14. Yes, this will be your answer. Do these calculations. You need to do these calculations. 8 into 10 to the power of 14 Hertz you will get. Okay, na? Yeah. So 21 is over. Next 22. Question number 22. Easy question. What they have asked? They are asking, what is the value of Planck's constant? Value of Planck's constant is 6.63 into 10 to the power of, see, Planck's constant value is 6.623 or 6.63 into 10 to the power of minus 34 joule second. Yeah. So all are 6.63 10 to the power of minus 34. All are same. But only the thing is they are using the unit different. See, first unit is joule per second they are given. So it is wrong. Second unit kg meter square per second. Third unit is kg meter square. Fourth unit is joule into per second. Means again it is nothing but joule per second only. So it is also wrong. These options will be 2 or 3. What is joule, Nana? Joule is nothing but unit of power that is nothing but kg meter square per second square. Okay, this is joule. So when you multiply joule with the second, you'll get kg meter square per second square into second. Second cancel. You'll get kg meter square per second. Yes, this should be the unit. Yeah, where it is? Yes, here. Option 2 is there. Did you got? See, not only the value you need to remember, you need to remember the unit also. Unit also you need to remember, students. Getting no? Okay. Next. Question number 22 over. Question number 23. When ultraviolet rays incident on a metal plate, then photoelectric effect does not occur. It occurs by which incident radiation? Okay. See, concept we need to understand here is, see, they are given that ultraviolet radiation or incident on a metal plate of metal plate, then photoelectric effect doesn't occur. They are saying, okay, that means what? We know that for photoelectric emission to occur, the on the metal plate, the instant light frequency should be minimum frequency should be there, or wavelength should be maximum. Okay, that means with ultraviolet light, there is no emission of photoelectron, means you should change the light which is having still more frequency or less wavelength. Clear? Now among these 1, 2, 3, 4 given rays, which is having more frequency or less wavelength, we need to see. Okay, yeah, infrared rays, X-rays, radio waves and light rays. However, light rays are nothing but ultraviolet layer. All the X-rays, infrared rays, microwaves, gamma rays, UV rays, all are light rays only. So light rays is not option. Now you are having 3 options. Now among these 3, which is having higher frequency than ultraviolet? Easily we can say X-rays. That means you need to remember the wavelength ranges of all the rays. Do you remember that? I have given one code for you. Remember me, I am very useful, extraordinary, guy or girl. I told you. Here R remembers radio waves. Radio. Me remembers micro. I indicates infrared. V represents visible rays. U indicates UV rays, X-rays and gamma rays. In this pattern, if you remember, if you go this side, means from radio waves to gamma rays, frequency is increasing like this. Okay? Yeah, now. Okay, so you need to replace UV rays with X-rays or gamma rays. Here X-rays is given option, so X-rays I am taking. Why we need to replace? Because some minimum frequency is required. Below that frequency, no photoelectric emission is occurring. That is law of photoelectric effect. So below this frequency, if you use this radio, micro, visible or infrared, photoelectric effect electrons will never eject out. We need to use still more than this UV rays. Means X-rays only the option given here. So X-rays is the answer. Got it, students? Important concept. You need to remember these all the points. Very important points. Clear? Okay. Question number 23 is over. Next question number 24. What they have given? See, a photoelectric cell is illuminated by a point source of light 1 meter away. Photoelectric cell is illuminated by point source of light 1 meter away. When a source is shifted to 2 meters, then each emitted electron carries 1/4 of initial energy. Number of photoelectrons emitted is half. Each emitted electron carries half of the initial energy. Number of photoelectric emitted electron is quarter of the initial number. See, Number of photoelectrons, just now I told you, it is inversely proportional to square of the distance. Whereas energy carried by that photoelectrons does not depends upon the distance. Whatever may be the distance, energy remains same, but number of photoelectrons will change. This is the point you need to remember. Means energy does not change. Okay. Yeah. Now distance is moving from 1 meter to 2 meter. See, means distance is increasing, means number of photoelectrons should decreases. Okay, directly I am saving this answer without using mathematical calculations. So it has to decrease. Okay. How much? 2 is there. 2 square means 4 parts, means 1 by 4th it has to decrease. See, number of photoelectron emitted is quarter of the initial number. Yes, option 4 is right answer. First option G, the emitted photoelectron carries 1/4 of initial energy. Energy should not change. Energy never changes with the distance. Only the thing is number of photons will change. How? Like this. You can say N1 by N2 is equal to D2 by D1, D1 square, D2 square by D1 square. N1 is N2 take. N2 is N2 only. Okay. D2 is 2 meter, 2 square. D1 is 1 square. Means N by N2 is equal to 4 by 1. And then what is N2? N by 4. Cross multiply it. Yes. Means number of photons is reducing by 1 by 4. Means quarter. Yes. Quarter. Yes. Correct. Option 4 is right answer. Got it? Getting no students? Okay, na? Clear? Yes, 24th question is over. Now let us go to question number 25. So before going to that, how many students? 19 are there. Okay. Yeah. So they have given that a graph shows variation of current I on y-axis into photo cells A and B as a function of applied voltage V. Okay. Current versus voltage graph they have given. Okay. When a light of same frequency is incident on a photo cell, frequency is same. Which of the following is correct conclusion drawn from the data? Okay. See, from this data, what we can say is, see, first option they are given that cathode of two cells are made up of same substance. Cathode is made up of same substance, but intensity of light are different. Yes, see, from these curves, this intensity is different. Intensity is different, right? But what about cathode of two cells made up of same substance? Means cathode is different, means tapping potential is same. Cathode is same means stopping potential is same. Stopping potential is same means frequency also same. Are you understanding? That means first option is correct. You have to understand this point. Next, second option they given that cathode are made up of different substance. Cathode is different means stopping potential is different. Stopping potential difference means frequency also different. But here frequency is same here. So second option is wrong. Third option, cathode substance as well as intensity of light are different. Cathode is not different. So wrong. No conclusion can be drawn. Yes, option 1 is the right answer. Got it, students? Explanation? Okay. Next, question number 26. What they have given? See, this graph is important. Frequently they will ask this type of graphs. See, listen, Nana, listen carefully. According to Einstein photoelectric equation, okay, what they are asking, the graph between kinetic energy of photoelectrons ejected and the frequency of incident radiation is what? Okay, according to photoelectric equation, kinetic energy equation is nothing but incident radiation energy minus work function. No? Yes. So this kinetic energy graph can be written as E is equal to E means what, Anna? H frequency we can write HF, no, minus work function is H into F naught we can write. Now they have drawn the graph between kinetic energy and the frequency. Okay, it is in the form of Y is equal to mx minus c. Okay, What should be the graph for this mx minus c? So m is the positive slope, minus c indicates here. Yes, the graph should be like this. Okay, this will gives you positive slope. Here frequency is here kinetic energy. Are you understanding? Yeah, means graph should be like this. Which is the graph among these two? This third graph is right answer for that. Don't tick for one. Option one is wrong. This indicates y is equal to mx plus c, but your equation is mx minus c. Mx minus c equation, your equation is mx minus c. So that's why it should be started from negative y value. It is starting from positive y value, so it is wrong. Got it, students? So graph is important. Remember this type of graphs. Very important. Okay. Next, 26 is over. Next, 27. Let us go to 27. Yeah. See, I think so. It is readable only. Okay, no problem. According to Einstein photoelectric equation, the plot of kinetic energy of emitted photoelectrons from a metal versus frequency of incident radiation gives a straight line whose slope is s. Just now we have drawn kinetic energy versus frequency. Here kinetic energy. Okay, yeah. So if you draw the graph, you will get a graph comes out to be like this. Okay. So what is the slope of this graph gives you? Okay. The slope of, they are given that, then straight line. Whose slope is? What is the slope? Depends upon intensity of radiation. Okay. Clear? They have given depends upon intensity of radiation. No. See, in this kinetic energy equation, we got HF minus HF not only. Where is intensity in this equation? So first option is wrong. Next, depends upon nature of the material used. Yeah, nature of the material means this is threshold frequency. Depends, but this F also is there. So we can't say about these two. Depends upon both intensity of radiation and metal. No, intensity doesn't depend. So option 3 is wrong. Next is same for all the metals and independent of intensity of radiation. Yes, option 4 is right answer. Okay. This kinetic energy, this slope, the slope of this graph gives you what now? H by E. Slope of this graph gives you H by E. This H by E is independent of nature of the material and independent of intensity of radiation. So option 4 is right answer. Now. How many of you understand this point? How I am explaining this explanation? Got it now, students? 27th question explanation. Slope of this graph gives you H by E, Planck's constant upon charge of the electron. This H and E values doesn't depend upon the intensity of radiation and metal, nature of the metal. Okay, clear? Yeah. So option 27 is, option 4 is right answer. Next, question number 28. A photon of energy 4 electron volt. Photon of energy 4 electron volt. Energy is equal to 4 electron volt. Okay. Incident on a metal surface whose work function how much Lana? 2 electron volt. Okay. The minimum reverse potential to be applied for stopping the emission of electron. Okay. Stopping potential we applied. We know stopping potential, that is nothing but work done we need to apply, will be equal to kinetic energy of mv square. Yes or no? That is kinetic energy. Clear? Yes. You know this point. Okay. So this whatever the work we have to do, that work should be used to stop the electron. Means to stop the electron means to decrease the kinetic energy of the electron. That is the thing. Okay. Yeah. So we know according to kinetic energy equation, kinetic energy is equal to energy minus work function. And this kinetic energy is nothing but stopping potential is equal to 4 electron volt minus 2 electron volt. So E V naught can be written as 4 minus 2 is 2 electron volt. Yeah, volt cancel. We'll get stopping potential is 2 volt. So minimum voltage we require is 2 volt. Yes. Where here option 1. Got it, students? Understood? No? Question number 28 is 2 volts. Yes, it is also over. Next. Question number 29. Let us go to matter waves. These are very important concepts, Nana. Let us go to matter waves. Question number 29. Okay, what they have given? See, if E and P are the energy and momentum of photons respectively, then reducing the wavelength of photon. Okay, so they are given that energy of photon. We know that energy of photon E is equal to what, Nana? Energy of photon E is equal to hf, or it can be written as hc by lambda. And we know momentum of de Broglie, according to de Broglie, momentum of every moving particle is h by lambda. Okay. Now they are saying that reducing the wavelength, if you decrease the wavelength here and here, if you decrease the wavelength here, momentum increases. If you decrease the wavelength here, energy increases. Means reducing the wavelength increases momentum and energy. Okay. So P and E both decreases, wrong. P and E both increases is correct. P increases, E decreases, wrong. P decreases, E increases, wrong. So option 2 is right answer. Got it, students? What I am saying there? So when lambda decreases, energy and momentum both increases. Option 2 is right answer. Next. Question number 30. The kinetic energy of a moving electron E, then de Broglie wavelength is. We know de Broglie wavelength lambda is equal to h by p momentum. We know momentum p is equal to root of 2 times of mass into kinetic energy. Okay, this kinetic energy, if I replace with E, it will become root 2 me. That means its wavelength will become h by root 2 me. Yeah, so where it is? Option 3. This is the formula, you need to remember this directly. Okay, next. Electron has a wavelength energy of 100 electron volt. What will be the wavelength? See, very important question, Nana. For your board exam also they will ask. Students, they will ask this question, question number 31. For your board exam also. Okay. What is the energy of electron which is accelerated through a potential difference of V volt? Okay, the wavelength of electron which is accelerated to a potential difference of V volt is 12.27 by root potential difference in angstrom you will get. This is the value. So for doing this, we have some calculations also. That is very important for your board exams. CBSE students, you also need to remember one more questions, objective questions, 20 questions will be there, no? Your pattern has changed. There they may ask you this type of questions. You need to remember this. Okay? Yeah. So they have given that 12.27 angstrom by V value. How much given there? V value is 100 electron volt. Okay. Electron has energy of 100 electron volt. Then what is the wavelength? Okay. So this is different question. Electron has an energy of 100 electron volt. What will be the wavelength? 100 electron volt energy is nothing but energy is equal to 100 electron volt. This energy we can write E potential difference is equal to 100 electron volt. Electron cancel. So potential difference is 100 volt we can write. Okay. So 100 I am writing. Okay. Means 12.27 angstrom by root 100 means 10. Means it will become 1.227 angstrom. 1.22 angstrom. Where it is there? See 1.2 angstrom here. Option 1 is right answer. This is how you can do. Are you understanding? Clear? Or else another method also is there, that is difficult method. So we know energy is equal to hc by lambda. And what is lambda? Lambda is equal to hc by energy. Okay? Yeah. H value 6.63 into 10 to the power of minus 34. C value 3 into 10 to the power of 8. Energy is 100 electron volt given. 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So if you calculate this total, you will get 1.2 angstrom approximately. However, this also you will get the answer. But that gives you short method. Previous method, whatever I have given, that gives you shortcut method. Clear? Okay. Important point. Remember. So option 1 is right answer. Got it? Next. 32. Question number 32, Nana. What they have given? See, question number 32, they have given that the ratio of wavelength of deuteron and proton accelerated through same potential difference. Yes. Very important questions for your competitive NEET and JEE students. NEET and JEE both. And CBSE students and board students, PU board students, this type of questions they will ask for 2 marks. Yes, this type of question is there in your senior's final exam paper. This type of question is there. Once you revise that question paper, you can see this type of questions. Very important, you have to answer them. And easy also. And for JEE and NEET also they will ask this type of questions. No, don't forget. Okay, yeah. They're asking ratio of wavelength of deuteron to proton. Okay, what is deuteron? Deuteron is nothing but H12, and proton is nothing but H11. This is charge number, this is mass number. You know this in chemistry. Okay, yeah. So we know de Broglie wavelength lambda is equal to H by mv, or it can be written as root 2 MeV. Potential difference is given. Okay. Yes. E means nothing but charge. 2m QE we can write. 2m QE. Okay, na? QE. This is a formula now. Yeah. Yes. Now here voltage is same and H also same. 2 is also same. Means lambda is inversely proportional to root of mass of charged particle and charge of the particle. Okay. Yeah. So they are asking ratio of deuteron to wavelength of proton. Ratio of wavelength of deuteron to proton is equal to under root of mass of proton charge of proton by under root of mass of deuteron charge of deuteron. We can write it because inversely proportional. No, that means this total under root of mass of proton charge of proton by mass of deuteron charge of deuteron. We can write. Okay, means mass of proton I'll write MP only, mass of charge of proton also QP only I'll write. Okay, yes. Mass of deuteron 2 times no this, yes, 2 times of mass of proton I'll write. Okay, are you understanding? And charge, however, they will be same charge, means charge of proton only we can write. Yes, this cancel. You got lambda d by lambda p is equal to under root of 1 by 2, means 1 by root 2 it is. Clear? Are you understanding? Yes. 1 by root 2 is the answer. Got it, students? Important point. You need to remember this type of questions. Very important. I think in first year chemistry also you have solved this type of questions. Clear? No? Understood? No? Yes. Next. Question number 33. What they have given? See, an electron is accelerated from rest. Okay. Between 2 points A and B, at which potential are 20 volt and 40 volts respectively. Then de Broglie wavelength associated with electron. See, when electron is given, then only we can write a de Broglie wavelength of electron is equal to 12.27 angstrom by root of potential difference. They are given 2 points A and B. Point A is at a potential of 20 volt, point B at a potential of 40 volt. Then what is the potential difference, Nana? Yes, 20 volts we can say potential difference, 20 to 40. Okay, that means it will become, wavelength will become 12.27 by root 20. Clear? Yes. So if you solve this in angstrom, okay, if you solve this root 20 value, somehow you will get, okay, calculator you take, you can solve. So you will get 2.75 angstrom answer. Solve this, Nana, you will get the answer 2.75 angstrom, because root 20 how much? I am taking calculator. Root 20 value is under root of 20 I want. Root 20 value is 4.47 approximately. Root 20 value, Nana, root 20 is 4.47 approximately. So divide with 4.47 here, you will get the answer 2.75. Yes. Clear? See here, meters given, wrong. Here angstrom given, right? Meter is not answer because your answer you are getting in terms of angstrom. No. Don't get confused. Okay? Yes, 33 is over. Next, 34. Question number 34, Nana. What they have given? See, electron is moving with a velocity of 6.6 into 10 to the power of 3 meter per second. De Broglie associated with the electron. Okay. De Broglie wavelength lambda is equal to h by p, means nothing but h by mass into velocity. So mass given, mass of electron is given. If not given also we know 9 into 10 to the power of minus 31 kg. And velocity is given 6.6 into 10 to the power of 3 meter per second. And Planck's constants also they have given. Okay, so if you do this, you will get the answer as 1 into 10 to the power of minus 7 meters. Calculate, just substitute and calculate, you will get the answer. 1 into 10 to the power of minus 7. Next, question number 35 is very important question. Concept you need to remember. Okay, the energy that should be added to the electron to reduce its de Broglie wavelength from 10 to the power of minus 10 meters to 0.5 into 10 to the power of minus 10 meter will be. De Broglie wavelength has to reduce from 10 to the power of minus 10 to 0.5 into 10 to the power of minus 10 meters. For that, how much energy we need to add? They are asking. We need to add. See, they are not asking what is the final energy. They are asking how much we should add. See, question C. How much final energy they are not asking. How much we should add they are asking. Okay. So see here. De Broglie wavelength and energy we have one relation, that is lambda is equal to h by root 2m into energy, means kinetic energy you can say. They did not say anything about mass, means it is constant, and h also constant, means lambda is inversely proportional to energy. Are you getting, students? Yes. Means we can say lambda 1 by lambda 2 is equal to under root of E2 by E1. Correct? Yes. Root E2 by root E1. I am writing under root of E2 by E1 directly. Okay. So lambda 1 how much given? 10 to the power of minus 10 in meters. Lambda 2 how much given? 0.5 into 10 to the power of minus 10 meters is equal to root of E2 by E1 given. Okay. 10 to the power of minus 10, 10 to the power of minus 10 cancel. 0.5 means what? 1 by 2 means 1 divided by 0.5 means 1 by 2 I am writing is equal to root of E2 by E1. Yes, 1 by 1 by 2 means 2. 2 is equal to root of E2 by E1. Correct? Square on both sides it will become 4 is equal to E2 by E1. Yes. Then what is E2 Nana? E2 is 4 times of E1. This is what? Final energy. But how much we should add? They are asking how much we should add. Final energy becomes 4 times of E1. What is the meaning of final energy? We know delta E is equal to E1 plus E2. Are you understanding? So this total energy, final energy should become 4 electron volt. For energy, for E1 should become is equal to E1 plus E2. How much we should do? So how much we should add? Send this side, it will become 3 times of energy. Means how much we should add? Twice equal to initial energy, wrong. 4 times is wrong because this is the final energy. How much we should add? So twice is wrong. Thrice the initial energy. Yes, this much we should add. Then only it will become 4. For initial energy E, if you will add 3 times of E, then only you will get 4 times of E. That means how much we should add? 3E energy we should add. So thrice the initial energy we should add. Option 4 is right answer. Understood? Okay. Clear, students? Next. Question number 35 is over. Next, go to question number 36. Yes, important question again. Question number 36. Important question again. CBSE students, they have asked this type of question. previously for your board exam, and PU students also need to remember, and competitive also it is important. See, magnitude of de Broglie wavelength of lambda of electron, proton, neutron and alpha particle all having same kinetic energy of 1 mega electron volt in increasing order will follow the sequence. See, de Broglie wavelength lambda is equal to h by root 2m kinetic energy, you can say, because kinetic energy is same, they are saying, means lambda is inversely proportional to square root of its mass. They are saying that proton, first they are asking electron, okay, first they are saying about electron, and then proton, and then neutron N01, and then alpha particle helium-24. Yes, this is electron, this is proton, this is neutron, and this is alpha particle. See, as we know that de Broglie wavelength will be more when mass is less, and de Broglie wavelength will be less when mass is more, because they are inversely proportional. And we need increasing order, means for smaller to larger we want. So de Broglie wavelength small will be for maximum mass. Maximum mass is for what? Alpha particle. So lambda alpha first we get. Then thereafter maximum for what? Maximum, both are proton and neutron, both are same, but compared to proton, neutron mass will be more. So lambda of neutron we should write. Next, lambda of proton, then lambda of electron. Yes, this should be the sequence. They are asking increasing order. I have written decreasing order. So increasing order means lambda of electron, lambda of proton, lambda of neutron, and lambda of alpha. This is increasing order. This I have written decreasing order. Clear? Are you understanding? Clear? 36. Increasing order, no? So small for the, yes, sorry, this is only increasing order. So this is the answer. Don't get confusion. Okay, so what I'm saying, see, smallest increasing order I want means smallest I want. Smallest is for more mass for helium. Yes. So this is the smallest value. Remaining all are largest. So it is the increasing order only. Increasing order. Clear? Yes. So alpha, first alpha where is there? Here it is. Option 3 is right answer. Got it, students? Understanding, no? Clear? Okay. So this is for today's class. Remaining questions we will continue in next class because time is over. Okay? Yeah. Thank you.